South Africa, a country well known for its wildlife and beautiful natural environment, is currently the world's hub of the renewable energy industry. Dozens of wind farms and solar plants are under construction in order to alleviate the current energy crisis, as well as help the country enable its future development. KougaWindFarm is one of the first projects that have been approved by the government in the round of Renewable Energy Independent Power Producers Program. We will show you step by step how such a massive and challenging project is constructed.
Building a wind farm is quite a complex process, as it consists of many disciplines that needs to come together on time. The first part of the wind farm consists of the civil balance of plant, which is your roads, your crane hardstands and your turbine foundations. While this is happening, we do the electrical balance of plant, which is your substation, control building, collector cable network and your turbine transformers. While the construction on site is happening, components are being manufactured in overseas countries and then shipped to South Africa. The last part of the shipping, which is via road, is quite challenging, as we have to contend with low bridges, small narrow roads, as well as sharp bends and turns, as we are normally situated in quite remote areas. When components arrive on site, the erection process is started. For erection, you need to have low wind conditions, which is normally a challenge on a wind farm site. After erection, turbines are commissioned and tested and proven to be reliable. When the commissioning has taken place, we connect to the Eskom grid and we do all our final testing, and we have to prove to Eskom that the power we generate is in line with their requirements. For the KougaWindFarm, Eskom had to build a 27-kilometer overhead power line as well as a switching station, and also extend some of the existing substations at the other end of the line.
KougaWindFarm is going to be built in Oyster Bay, situated 22 kilometers southwest of Humansdorp and 14 kilometers west of St. Francis Bay on the Eastern Cape coast of South Africa. Oyster Bay is known for the beautiful and extended untouched beaches, surrounded by high sand dunes, and renowned among tourists for its excellent calm atmosphere, surf and deep sea fishing.
Hello, my name is Sergio. I come from Spain and I work as site manager for the company Nordex here at KougaWindFarm. Oyster Bay is an ideal location for the installation of a wind farm, as this area is very windy. The wind is very constant during the day and it drops slightly during the night. The average wind speed is over 9 meters per second. These wind conditions are great during the operation of the wind farm, as this wind farm will produce a lot of energy, but at the same time are a big challenge during the construction. Bearing in mind that maximum wind speed during the installation of the wind turbines is around 10 meters per second. The area where KougaWindFarm is located is very flat. This will help the relocation of the cranes during the installation and the transport within the construction site of the main components of the wind turbines. Oyster Bay is an area of beautiful and extensive landscape. These lands are owned by local farmers who dedicate their life to graze and cattle farming. During the construction of KougaWindFarm, we established good relationship with them and try to minimize the disturbance of their daily activities.
My name is Ulov Silier. I'm a dairy farmer here in the Tsitsikamma area, close to Oyster Bay, a small coastal village. I'm married with 2 children. I'm a dairy farmer and we milk about 400 cattle twice daily. Oyster Bay consists mainly of dairy farmers, so it's a big farming community. Then there's quite a lot of fishermen as well. Oyster Bay itself is a holiday place. KougaWindFarm is a good thing that happened to all of us as a community. A lot of job creation was done by KougaWindFarm. There's quite a big portion of people in the area that is unemployed. So for them, for the past 2 years, it's been quite a good income. It was job creation basically in the area. I think it's definitely the way forward, cleaner energy.
The area is very sensitive from an environmental point of view. A large variety of birds and wildlife inhabit the area. Before and during construction of the wind farm, several precautions were taken to minimize the disturbance of animals, landscapes, and persons living in the area. KougaWindFarm has implemented the comprehensive environmental management program to avoid sensitive areas and has involved independent consultants to ensure that the impact of their construction on the natural surroundings is kept to a minimum. The wind farm has entered into a proactive agreement with the Endangered Wildlife Trust to monitor key bird species in the area and is working with a local conservation NGO and other wind farm developers to identify and implement a conservation initiative in the Kouga region. The civil contractor, Power Construction, is responsible for the civil works on the site.
Early in 2011, Power identified the opportunity to widen its base by investing time in procuring work in the renewable energy market and further strengthen our position as market leaders. Power has secured 3 civil balance of plant contracts of the 8 projects awarded in Window 1, totaling 257 megawatts of the 634 megawatts awarded, making us the leader in this segment.
Power Construction, together with RHDHV as our design consultants, was contracted by Nordic South Africa to perform the civil construction duties on the KougaWindFarm. The site compound for the management team is established at the beginning of the construction works. The main challenge is to provide proper running water, electricity, ablution, welfare and network facilities for the staff working on the project. For the road network connecting the turbines, we use material from both borrow pits as well as commercial sources on site. The network is designed and constructed to minimize the impact on agricultural land and maximize the stormwater drainage during the construction phase of the project. The construction of the haul roads includes stripping of topsoil, cut to fill bulk earthworks, cutting of in-situ roadbed, importation of road building final aggregate, stormwater installation, and final polishing and trimming. We utilize 30 number 10 cubic meter tipper trucks carrying the material from the quarry to the site. We import on average 100 loads per day for the duration of the project to be able to complete our milestones in time. The excavations on site can be split in 2 main portions. One is within a silty sand, highly saturated material, where the second one is in a quartzitic sandstone rock formation, which does take more effort to excavate. A 150mm concrete layer is placed on top of the in-situ prepared material in order to provide a level working surface for the bolt cage, steel and shutter team for the main port to continue. For the bolt cages to be installed as part of the bases, we use parts manufactured and imported to the ports out of Europe by Nordic South Africa. The average cage weight is 9.5 tons delivered on pallets, which takes on average 1 day to install with a crew of around 6 people. The bolt cages consist of 2 plates at the bottom connected to each other with 160 bolts and 2 load spreading plates at the top, all bolted together. The bolt cage is placed in the center of the base in order to erect the turbine mast on top. For the steel supply on the project, we subcontracted with a local company out of Port Elizabeth, RSC, to supply and install all the steel cages on the project. The bases require 55 tons of 500 MPa steel in order to complete a base for the main port. The teams of about 12 people take 6 days to complete the binding of one base until completed. The total tons required over the next 6 months will be 1,800 tons to complete all bases for the project. For the main concrete pours, we contracted with a local subcontractor out of Port Elizabeth, Chris House Construction South Africa, to do the main pours as well as pumping of the concrete mix into the base. We have two different types of bases on site. One is a 20-meter diameter, the second is a 22 diameter base. The 20-meter base consists of 460 cubic meters of concrete. The 22-meter base consists of 540 cubic meters of concrete to complete the pour. The pour time required for a small base is 17 hours at an average pour of 29 cubic meters an hour. The 540 cubic meter base takes 19 hours to complete from start till stop. The start of the main pour starts at 6 in the morning and finishes usually at around 11 in the evening. The finishing crew will then come in and finish off for the next 5 hours until the base is complete. We use thermo blankets for the curing of concrete for 7 days after the concrete is complete. The main purpose of the thermo blanket is to control the internal heat of hydration process during this period. The next step of the foundation is to do the backfilling in layers. The backfilling of the bases are done with the excavated material where suitable, in uniform layers up to the final level of the plinth. The grouting product supplied by BASF South Africa was Masterflow 885, used for grouting the 50mm gap below the LSP plate and the concrete plinth in order to transfer the turbine loads to the concrete foundation effectively. The product had its own challenges in terms of the technical requirements for the turbines and was successfully overcome through trials and laboratory testing by our technical crew. The side challenges was ambient conditions, heat and wind, surface and water temperatures, as the plasticity and flow of the product is influenced by this. The placing time on average per base was 1 hour from start till finish, using on average 55 bags per base. The crane pad is constructed to the side of the base using the same methodology as used on the roads. This area is mainly used to place the component parts of the turbine until the turbine is complete.
The electrical infrastructure of KougaWindFarm includes the medium voltage cables that connect with different wind turbines to the wind farm substation. All power generated by the wind turbines is collected, controlled, and sent to the national grid for distribution to end users. The substation includes the operation and control building of the wind farm, as well as the yard where the high voltage electrical components are installed. The main components of the substation are the two main transformers. These increase the voltage of the power generated by the wind farm from 33 kilovolts to 132 kilovolts. Each wind turbine is connected to the next wind turbine and to the substation by means of medium voltage cables. These cables are buried in cable trenches that run alongside the roads of the wind farm. More than 150 kilometers of aluminum cable has been installed in approximately 30 kilometers of cable trenches. The pad mount transformer kiosk is installed at each wind turbine. It contains the medium voltage switchgear and transformer required to control and increase the turbine output voltage to 33 kilovolts. The kiosk is mounted on a concrete foundation specially built to accommodate and support the weight of the equipment. In order to transfer the power generated by the wind farm into the national grid, Eskom constructed a switching station and electrical overhead power line to connect the wind farm substation to the Mulcote substation, located just outside the town of Humansdorp. The power line is 28 kilometers in length and has 95 supporting structures. This line also provides the communication link between the wind farm and the Eskom grid control. Key to the development of the KougaWindFarm is ensuring a strong positive impact on the communities and areas in which the wind farm is involved. This includes building relationships with the community, facilitating community participation in the wind farm through a broad-based empowerment trust, as well as investing in the communities themselves. During construction, the KougaWindFarm Corporate Social Responsibility Team have been involved in the various community-led initiatives in the towns of Sea Vista and Umzamawetu.
So my first activity here at the wind farm was to get involved with the soup kitchens in Sea Vista here in St. Francis Bay. It's a little township here. We established their needs, and from there we were able to organize food and vegetables on a regular basis for them.
The wind farm is working closely with Kouga municipality and local communities to identify priority projects and to develop a long-term economic development plan, which will be implemented once the wind farm is commercially operational and generating income for the KougaWindFarm Community Development Trust. The trust holds a 26% shareholding in the project company and will derive income from the sale of electricity to fund health, welfare, education, local infrastructure, and enterprise development projects. The transport of the main components of the wind turbines has been a huge logistical challenge and a great success, as the transport team managed to deliver 350 abnormal loads in a period of 5 months without any incident. The wind turbine components were transported from different parts of the globe to the port of Kouga, located in Port Elizabeth. The tower sections arrived from South Korea, the blades from China, and the nacelles, drivetrains and hubs from Germany. ALE was the company in charge of the offloading and the storage of the components at the port, the transport from the port to the construction site, and the offloading of the components on site. The components are offloaded from the vessels by means of onboard cranes and are then stored at the port until required on site.
Basically on board we have about 48 blades which are currently on there, and 32 tower sections which will also be offloaded if all the blade operation goes well.
It is crucial to plan deliveries properly and to have fluent and constant communication between the team located at the port and the construction site in order to coordinate the transportation on a daily basis. The goal is to receive the required components on site safely, on time and without damage. To minimize disruption to the public using the roads on the delivery route, the Kouga Wind Farm used a SMS system to communicate to everyone each day on the exact times of loads leaving port, as well as expected arrival times at site. This public awareness and communication system worked perfectly and helped to make this logistical challenge a smooth and well-orchestrated exercise. Once the construction site and the port have agreed which components are required, they are transported by large, specialized vehicles which are classified as abnormal loads due to their size and weight. The distance between the port and the site is around 150 kilometers, mostly along the N2 highway. Each abnormal load is accompanied by 2 escort vehicles, one in front and one behind, to increase visibility and prevent accidents with road users. A traffic safety coordinator liaises with the local and provincial traffic authorities.
What I usually do is to negotiate with the traffic corps before the project, make sure that they are aware of the project and how are we going to work out the road management system. Okay, now I have to overtake all the trucks so that I can block the traffic in front, and then the traffic cop is going to pass me to get to the next junction so that we make sure that the trucks don't delay and we avoid accidents.
Once the loads arrive on site, the components are offloaded at each turbine position, ready to be installed. We proceed to the installation of the wind turbines. The company that makes it happen is Windhoist Turbine Erection Experts.
Hi, my name is Emmett Leeson. I'm site manager for Windhoist. We are responsible for the craneage and installation of 32 N90 Gamma turbines for Nordex in KougaWindFarm here in Oyster Bay. The first step in the process of installing the turbines is to get our cranes into position. We start off by choosing the correct crane pad, which we liaise with Nordex, the sequence of turbines on which they want to put up first. And then we pick the safest, quickest route for rigging the cranes. We position our cranes as per our drawings from our technical team. If we're lucky, if the weather's with us and the conditions are right, 4 hours to rig the cranes.
Well, the main crane being used here is an LTM 1500 8.1. The small crane is an LTM 1250. The capacity for that configuration is 58 tonne. It's got a 47.3 metre main boom and 42 metre lofer on it as it's built.
When the cranes are rigged, the transport team starts bringing in the base tower, which is the first component to be lifted. We get it into position so it's within radius of our cranes. Firstly we attach the main crane onto one end and attach the assist crane onto the other end. Once the base tower is lifted off the trailer, the transport company pulls its lorry away and we position safety support stands underneath the tower so we can rest the turbine just above the ground so the guys can get in underneath to clean. Once the guys have cleaned the turbine and all the rust spots and any damage noted is repaired, we then start to lift the turbine. We lift the turbine using the main crane and the assist crane. It's called topping and tailing.
Which is you connect the big crane and the small crane onto the tower. The big crane takes the lift, the small crane tails the tower in under the big crane until the big crane has the full weight of the tower. It's topping and tailing to keep the two cranes working together.
Once the tower is vertical, we release the assist crane. We then proceed to lift the tower for placement. We drop the base tower gently down over the bolts. We then proceed to rattle up the bolts to 1000 Newton meters. We then send our technicians up top to release the crane. We repeat this process 3 more times for the remaining 3 tower segments. Okay, once we have the 4 tower sections in place, we proceed with the nacelle. First step with the nacelle is to remove the roof. We then lift the nacelle off the ground higher so the technicians can get in underneath to clean the base of the nacelle and also the yaw ring. We proceed to lift the nacelle 85 metres to the top of the 4th section. The banksmen up top will lower the nacelle onto the top section and proceed with bolting. Technicians will climb into the nacelle and release the slings.
For a nacelle, the biggest problem for a nacelle would be wind. The nacelle, the shape of it, it's square, it's just like a square box. It catches a lot of wind, so wind would be the biggest issue there.
We now proceed with lifting the drivetrain into place. Drivetrain weighs about 47 tonne. When the drivetrain is directly over the nacelle, the technicians will lower the drivetrain onto the nacelle frame and we'll start attaching the bolts.
For the drivetrain, same thing, wind. We are moving it into the nacelle. It's very tight for space for men, so any wind causes a lot of movement in the drivetrain.
The next step in the erection of the turbine is the erection of the hub. We start this process with the assist crane. The assist crane will remove the hub from the transport frame and then we will attach the main crane. The hub weighs roughly 30 tonne. We will then proceed to lift the hub with the main crane, again turning the hub into position. Whenever the hub is turned into the correct position and the main crane has all the weight, we then remove the assist crane. We attach tag lines for control. We then proceed to lift the hub into place. Again, 85 metres, we're looking at 10 minutes. Okay. The next step is the installation of the blades. The first step with the blades is to insert the bolts on the ground. Once the technicians are happy that everything is in place, the banksman will signal to both crane drivers to proceed with the lift. The banksman will closely watch the blade and keep it level. Once the banksmen on top have visual of the blade, they will take over the lift. They will then bank the blade into position and attach the nuts. Once they have all the nuts attached, they will then release the main crane. They will then bank the assist crane off the tip of the blade. This is used by pulling down hard on a rope to release the sling. Once the sling is released, the assist crane will slew away from the blade. He is closely watched by the banksman up top. When both cranes are clear, they will then turn the rotor into position for the second blade. They will repeat the process for the second blade and then again for the third blade. When the third blade is installed, they will then remove the turning motor and reattach the roof.
After the wind turbine is erected, the finishing crew will start the electromechanical installation inside the wind turbine. When complete, the Nordex commissioning team will carry out a full complement of necessary inspections and tests before the wind turbine is confirmed ready to produce electricity.
When entering the turbine, the first thing you'll see is the main inverter. The main inverter is used to synchronize the power from the turbine to the grid. However, the other component is the Nordex component, which we know as the bottom box. The bottom box is the brain of our turbine, and this is where all the decisions are made. Before power is switched on in the turbine, a final check is done in the main inverter to make sure everything is ready. Then once power has been switched on, communication is established from the bottom box of the turbine to the nacelle of the turbine. The commissioners then ensure that all components are working properly. This is done by either uploading software or firmware and then testing that these are done correctly. Once commissioners are satisfied that all components are working and functioning, the turbine is then finished off by doing safety tests.
Once the wind turbine is connected to the electrical grid and fully commissioned, it will undergo a reliability test of 240 hours, during which the equipment must comply with certain requirements of availability and lack of repetitive errors. Additionally, the power generated by the wind farm has to comply with the South African grid code, and this will have to be proved by means of grid code compliance tests. Only when all these tests are passed successfully will the wind farm be handed over to the operation and maintenance crews. The KougaWindFarm will produce clean energy from the wind for the next 20 years.
Congratulations to all those involved in the successful completion of the KougaWindFarm. This is just the beginning of what promises to be a big industry for South Africa.
My name is Jorge Gonçalves. I came from Portugal to embrace this challenging and pioneered project in the Rainbow Nation, South Africa. Thanks to KougaWindFarm and Redcap as our customers and all our subcontractors, Nordex, as the engineering, procurement and construction contractor, was able to provide its entire scope, building all the required infrastructure to supply, install and connect to the national grid 32 wind turbine generators, whose components came from 3 different continents. All this was made on time, approximately 2 years of construction works, on budget, with the highest quality standards, and most important for Nordex, on a safe and healthy way, with 0 lost time incidents over more than 400,000 working hours. It's a huge satisfaction to contribute with such a project to improve the quality of life in South Africa in general and the local communities in particular. There is a famous Portuguese quote that says, "God wills, the man dreams, and the work is born." At KougaWindFarm, this was the case.
KougaWindFarm is now creating clean energy. It has been a huge challenge and a great effort to turn this project into reality. It is bringing hope to the local communities and a brighter future for South Africa. Thanks to all the people that made this achievement possible and such a big success.